In this video, we're going to be covering the cooling system. We're going to take a look at the antifreeze or the coolant. We'll talk about service intervals. We're going to talk about the cooling system components and then testing the system. Vehicles today are liquid cooled. You're not going to find the air cooled engines like you did back in the 60s. Reason: liquid is much denser, it is much more effective at transferring heat. It is going to be at least twice as effective and up to 10 times as effective at transferring heat than air. The second advantage to it, you can use it to target hot spots. On the head, we get particular areas that are sensitive to heat. We can drill a coolant passage through there and target the coolant toward those areas that you just can't do with an air-cooled system. On the automotive side, it's almost all ethylene glycol. On the heavy-duty side, they use some propylene glycol. You go back into the 60s, 70s, change the coolant once a year, once or every other year, depending on who you talk to, how often it should be. For myself, I was doing it every other year. Then, getting up to the late 80s, early 90s, somewhere in there, the manufacturers started changing over to a long-life coolant, where they're saying now it's good for 10 years or 100,000 miles. The old coolants were made from ethylene glycol. The new long-life coolant was made from ethylene glycol. The difference is the additives that they would put in there. The additives that they're putting in last much longer. Some of the additives, you can get water that has high pH or water that has high alkaline. They put additives in there that are going to help buffer that. That is what I've been told from a class that I went to, is one of the biggest differences between the coolant for Asian vehicles versus the coolant for the European vehicles, because of the water difference in those countries. They're also going to put in corrosion inhibitors. This is going to coat over your metal parts, your aluminum, to prevent it from corroding. You can read as much as you want about this. It gets really confusing because they talk about OAT or HOAT, which is the organic acid technology. I got to read about that and finally got I don't care. They put in corrosion inhibitors. They're also put in lubricants, and the manufacturers put in dye. They used to all use a green dye, but now each manufacturer uses their own color. The dye is supposed to make it easy to identify that it's coolant. It'll fluoresce. You want to use only the OEM coolant. Do not use the one size fits most. I've been hearing this for years. I was talking to people that would come up and say, no, you only use the OE. And I'm going, why? It's aluminum. They're seals. What's the difference? And they couldn't tell me. They just tell me to do it that way. And so I went to that one class, 4 hours listening to this guy talk about coolants. And that was the main reason I went to this class, is I wanted to find out why. And he was going through, he talked about that, shot my hand up, why? And he goes, because of the head gasket. The manufacturers make their head gaskets different. And it was like, that makes sense, because I have seen the head gaskets begin to leak. You get the wrong coolant, the wrong additives, it's not compatible with this material, and it'll begin to eat away those coolant passages. Once I went to that, okay, I'm a believer. Use OE coolants only. I'm going to show you the picture here. This is the O'Reilly's, and I'm not picking on O'Reilly's. This is going to be the same thing at Napa, at AutoZone, all the different ones. This universal coolant. And here's what they say. Coolant features long-life technology, is compatible for use in all automobiles and light-duty trucks. All automobiles, light-duty trucks, regardless of make, model, or year, regardless of the color. It is good for 150,000 miles or 5 years. That's the aftermarket coolant. They're telling you it's compatible with everybody. I've talked to professionals and they're saying, no, it's not. Then you keep reading and you find these standards. It meets these numbers. And try to look those numbers up. It is nearly impossible to find out what these numbers mean. Well, that guy that I took the class from was telling us these numbers are GM. That's their designation for their coolant. It meets this standard. The problem is, that was the old coolant, not when they went to their DexCool. Now, if there's an aftermarket equivalent, like there's a lot of aftermarket DexCool, I'll use that. I don't need to use the manufacturer's one if I can find the DexCool from another manufacturer when I'm doing GM. When you go to service it, they have a couple different kits. This is the more popular one because it's a lot less expensive. This funnel goes on top of the radiator, is held down by these adapters, and you can keep this thing full or half full of coolant as the engine is warming up. So as it begins to burp, you're not spilling the coolant all over the place. I like this one a lot better. To buy a good one of these kits, they're going to be $100 plus. This fits onto where your radiator cap goes, seals this. Then you hook up the air hose. It has a venturi, so it pulls the system into a vacuum. Once you have it in a vacuum, then I'll have a 5-gallon bucket with my mix, 50-50 mix of coolant. Dunk this in there so I get this tube completely full of coolant. Hold my thumb over it, bring it up, connect it up here, and then open this valve back up. Now the vacuum that you just pulled the system into pulls the coolant in there, and you fill the engine with coolant, nearly eliminating having to burp the engine. The problem with burping the engine is that you've got half of the engine block that now has air trapped in it. The thermostat's not going to open until it gets up to temperature, but it doesn't have the coolant, it just has steam coming off there as the coolant is boiling in the engine. Then the thermostat will open, takes a gulp of cool coolant coming in from the radiator, cools back down, thermostat closes, and you may have to do that 2 or 3 times before you get all the air. The danger in doing that is you're overheating the engine while you're doing it. So if you can eliminate having to burp the engine, that's best. This is the tool that works the best for it. If you've taken an engine part that has a lot of miles on it, you'll find that cylinder number 1 has the most wear. It's like 90% of your engine wear happens while the engine is cold. This cylinder runs colder than the rest, so it will almost always have the most wear on it. Coolant comes through each of your cylinders. Once it has gone through the block, it's then going to come back through the head, then to the radiator, come back in through the block. There are some manufacturers that use a reverse coolant system. They run the coolant through the head first. That cools the head down, allows them to run a higher compression ratio without the formation of NOx. Coolant then is going to come through the block, meaning the cylinder walls are hotter. If you have a high performance engine with a reverse cooling system, you have to run synthetic oil because your natural oils won't handle the high temperatures when you're really pushing that engine hard. Radiator and heater core, which the heater core is actually just a small radiator. On our older radiators, made out of copper, the tanks were copper, the fins, everything was copper on here. What was nice about that, it was repairable. Get a crack up here or a leak, solder it to seal it back up. These were mostly all a top flow. Manufacturers then went to a side flow, and they went to aluminum construction with the plastic tanks. On these systems, you get a crack or something on there. These are replacement. Looking on the inside of the radiator, if you can see it, hopefully you can, you're going to look at where these passageways are. On this one here, they had something in there, maybe an oil leak. So like in the head gasket, it opened up between the coolant and the oil passage and started getting something in here, was plugging up the radiator. You'll also look inside here on some, and they'll have a calcium built up on here, indication that the coolant has not been replaced as often as it should. If it's starting to get that, replace the radiator. You used to be able to take it to a radiator shop and they would reverse flush it for you. I haven't found a radiator shop that will do that anymore. It's strictly a replacement item. The other thing you're going to look at the radiator is the airflow. If stuff starts to build up on here, which this is a really extreme case, typically you'll find bird feathers, leaves, butterflies, moths that are stuck against here. You have to get those cleaned out. If it's one where there's stuff inside there, I'll use compressed air, blow it backwards through the radiators. You're not forcing the stuff through. I've seen guys use water to run it through. That's okay as far as I'm concerned, but don't use a pressure washer. You don't want to use a lot of pressure. These just aren't designed for that. Making sure airflow is clear, making sure the coolant passages are clear, all of this, trying to find out why is this engine overheating or why isn't the engine operating at the temperature it's supposed to. Third thing to look at is the cowling. If the cowling is broken, so motor mount broke, fan hit the cowling, or somebody got aggressive underneath there or leaned where they shouldn't have and this is starting to break apart, it needs to be replaced. You want to make sure the air is being forced through the radiator and through the condenser. The manufacturers will also put some sort of foam seal between the condenser and the radiator. Make sure that's in good condition so that you have that airflow through there that you need to. This is going to be for both the heater hoses and for your radiator hoses. Starting off in the center here, you can see there's rubber around this inside, and then there's this white stuff right there. This is your hose on the inside. The thread that you see that's wrapped around here is the reinforcing so the hose can handle pressure. And this outside is a jacket to protect the hose. What's going to happen, especially right where the band tightens down, and especially if a person over tightened it, it'll get a leak on the hose. Coolant gets up into here and it'll begin to separate this. Now the system gets under pressure and you see a bulge in this area right here. When you see that, shut it off, replace that hose. When that thing blows, it's like a shotgun when it goes off, and coolant goes everywhere. If the hoses are about 10 years old, you're going to recommend the customer to replace those. The other thing is, when you reach down there, squeeze it, if it feels like it's dried and cracked, again, needs to be replaced. You're going to check the clamps on these quick disconnects, make sure there's no leaking around there, make sure the clamps are clean, tight. These spring type clamps, like they're showing you here, those are the better type of clamp. The screw type clamps, you can get it on there, you can get it tight. As the hose ages, it's going to shrink. The screw type clamp is now going to be loose. These will self-adjust as that hose shrinks down. The other problem with the spring type clamp, not with the spring type clamp, but with the screw type clamp, is there's people that think, hey, well, if snug is good, tight is better, and the tighter the better. So they will over torque those. Most of the hose that you're going to buy is preformed because they give twists and turns inside there. If you just buy the hose reel, it's probably not going to fit in. It's going to fit in correctly. It's going to rub against somewhere. Then especially where you want to get ones that it's a different size at one end than it is the other. You have to buy the preformed. The tool for these spring clamps is going to be something like this. I'm not pushing this particular brand. This is just one of them. And this is actually not my preferred one, but it's the one I found an image for. These are so nice because this reaches down to the bottom of the radiator, gets that spring clamp loose. While you're working from the top, you don't have to try to get a tool down inside there. If you don't have one of these tools, recommend getting one. Typical thermostats are supposed to open between 180 and 195. You get some racing applications, some special performance ones. They may go with a little bit cooler. Majority of the automobiles that are out there between 180 and 195. Down here they show you the thermostat closed. This part right here, as it gets hot, is going to open this up and you have the cool flow through there. You can read and find out, okay, it's supposed to start opening this temperature, should be fully open by this temperature. I don't care about that. While I'm testing it, I'm going to have my hand on the upper radiator hose. When I feel it get warm or hot, I know the thermostat's open. I'm going to look to see what temperature it is. What I have found from teaching at school, I have the students test the vehicles. Those older vehicles that are in there, it is over 50% of the thermostats open too soon or are stuck open. Another thing I want to point out to you is that this little hole right there with that little piece inside there, that's to allow the engine to burp. When you fill it up with coolant, it'll allow the air to bleed out of the engine. When you install it, this goes at the top. If it doesn't have this piece in there, I will take an 1/8 inch drill bit and I will drill a hole in there because I want that engine to burp. I've quoted price of thermostats, which they usually aren't very expensive. Then I did one and it was over $100 because it had the mounting piece on there also, and I had to call the customer. So careful if you go to quote the customer before you look up the price of the part. Had a lady come in with a Ford, and she said that her heater would only blow warm, it wouldn't blow hot. So we were checking flow through the heater core, started it up, we're watching it. The thermostat opened at 160. All right, that's going to be the problem. So ordered the thermostat, we installed the thermostat for her, and the brand new thermostat out of the box opened at 170. And it was a 195 degree thermostat, opened 25 degrees too soon. So I started talking to technicians working in the industry, and the word that they were telling me is stant. The other one that I would go with is the original equipment manufacturers. Coolant recovery tank. Older vehicles, most all of them were like this, a non-pressurized system. This hose connected up to a nipple on the side of the radiator right underneath the cap. To check this system, just look to make sure it's going to hold coolant, it's not cracked on the bottom. Pull this hose off from the radiator, take an air hose, blow through. You can have some coolant in there, you see the bubbles come through. That system's good. Real simple to check. As you get to the newer ones, that part of the pressurized systems, there is no separate radiator cap. This is your radiator cap. A little more difficult to check, but I haven't seen very many of those go bad. I have seen a few that cracked, but other than that, I haven't seen a problem with them. These are actually nice when you go to burp the system after changing the coolant. It's easier to burp the system. Looking at the radiator cap, so this one right here shows you 1.1. That's the pressure. That's in bar, so 14.5 times 1.1. That's going to be about a 16 psi cap. Looking at the bottom side of the cap, there's a sealing surface here. There's a second sealing surface right here. This sealing surface right here is going to hold the pressure in our cooling system. When the pressure begins to get too high, this is going to open up. It's going to allow the coolant to get into this area. This seal right here is designed for low pressure. What that's going to do is make sure that the coolant that comes past here goes into our recovery tank, not onto the street. This little metal piece right here is what's going to prevent the system from going into a vacuum as the engine cools off. Here you can see this upper radiator hose is collapsed. If you open the hood, an engine is cooled down, and you see this radiator collapse, the system is in a vacuum, that part has failed. You need a new radiator cap. The other test I do on these, hold it upside down. If this thing just dangles down, which should be a fairly weak spring inside there holding it up against there, but if it just dangles down, it's not going to be able to build up pressure on the vehicle. Checking the radiator cap, check your sealing surfaces here, make sure they're in good condition, turn it upside down, make sure this thing doesn't dangle. Then you're also going to use a pressure tester and make sure this holds the pressure that it's rated at. Pressure tester that's like this, and this is the one size fits most. Some of these are good, some of them are not so good. If you go to buy one of these, check reviews, make sure that people like them. This style right here, this is the Stant pressure tester. It's good, a quality tester. The limitation to this is they only give you one adapter. To use this on a lot of the vehicles that are out there, you have to spend the money to buy the adapters. For myself personally, I like this tester. It's good quality, it stands up. However, too many students use it, drop it, and then it will not become reliable. But for technicians working out in the field, this particular tester will stand up for a long time. When you pressurize the system, you're going to watch to make sure that it holds the pressure. You're going to pressurize it to whatever your cap is rated at. Then let it sit for a few minutes and make sure that it holds that pressure. If the pressure is dropping down, bump it back up, keep it at that pressure, and start looking around for the coolant leak. On the water pump, looking at it over here on the left, we have our impeller. There's a shaft that comes through here. And this is where your belt drive is going to be, or typically a belt drive. There's a seal inside of here and two bearings. In between these two bearings is this hole right here, or this hole right here. Those they call a weep hole. When you look at this hole, if there's even a drop of coolant in there, replace the water pump. This one has had a coolant leak for quite a while. In order for the coolant to get to this hole right here, the coolant had to come past the seal, which means the seal has gone bad, and it had to come through the bearing. It's going to take the grease out of that bearing, which means that bearing is going to fail. Goes along for a long time, holding good, and then it begins to fail a little bit because the grease is now going to be wiped out of this bearing. The bearing's going to wipe out. It's going to allow this to wobble, and so its failure rate is going to be like that. When you see just a drop of coolant, you're going to tell the customer you need a new water pump now. If the water pump is driven by the timing belt, you're not going to pull all the plastic off there to look at that water pump. I'm going to look from underneath the car, the plastic around the timing belt cover. If there's coolant leaking out from down there, and there's no visible leaks anywhere else, it's coming from the water pump. I have worked on some of Volkswagens that had the plastic impeller. That plastic impeller cracked. The first one, man, it kicked my butt. I could not figure out why this vehicle overheated. If I kept the engine RPM low, the engine would stay cool. Get up above a certain RPM, the engine begins to overheat. And man, I am racking my brain trying to figure out what is causing this particular problem. Pulled the water pump off, found that that impeller was cracked, so it would slip at higher RPM. Put a water pump on with a metal impeller. I went away from the plastic. I've been told that those plastic ones are good now. Yeah, I've been burned once. I'm going to go with the metal blade. Radiator fans. Looking at the belt-driven fan, and this is a viscous coupling. Has a liquid inside here. When you first start it up, the liquid's going to be down at the bottom. The fan's going to be really noisy. I mean, noisy like the fan is trying to pull the vehicle down the road. Within about 30 seconds, it should quiet down. There's your first test. A second test that you're going to do is you're going to look particularly at the front right here. If there's evidence of leakage, that means this viscous fluid inside of here is starting to leak out. Needs to be replaced. Third test, come up and grab the fan blade and shake hands with it. If it will shake hands with you, you got a bearing going bad, needs to be replaced. So 3 tests on those. They're designed to free spin on a lot of them. Start the engine up cold, you'll hear the fan get really noisy and quiets down. And I'll take a rag, my hand, and I'll stick down there, and there are most of those you can stop the fan while the engine is running. The electric fans, we're going to take a look at those on the next slide. Here's our electric motor. Fan on the one side. You can see with just the fan on the one side, this thing is not balanced, so it is going to wear uneven. Right here, there's our electric motor. This is a relatively simple one. We have a relay, controls the fan. The relay is controlled by the engine computer. 2 fans, 2 relays, computer controls each one. And this is saying primary and secondary. If the coolant temp gets up to a certain point, or if the AC is turned on, it's going to turn on just one fan. Temperature gets above a certain point, or it's hot and the AC is on, then it'll run both fans. You get up above 35 miles an hour or so, they may shut the fans off because there's enough airflow through the radiator to keep the engine cool. If the engine gets up above a certain point, then they'll kick the fan back on. On some of these, you will find that there's 2 motors. It turns on low, both the motors run, but on low speed. They're going to have some resistors in there on each of those. They'll run on low speed and then on high speed. You'll find another one that has the duty cycle controlled. It's going to have this heavy box with a heat sink on there, and they'll run this at variable speed. There's a bunch of different ones. The fans can be pullers, meaning they're behind the radiator, or pushers mounted in front of the radiators. I've seen up to 3 fans mounted on the radiator to try to get enough airflow through there to keep the engine cooled down. Problem that you're going to run into as this begins to wear, that shaft through the motor is like this. As it begins to wear, and exaggerating what's happening here, this is going to begin to go out of alignment because our fan is down here. When this shaft gets out of alignment inside the motor, the magnetic fields are out of alignment, the motor turns slower. DC motors, the slower they turn, the less resistance they have, the more current's going to flow through there. Here's where our current's going to flow through, down to ground. Our weak spot is the contacts right there. Those are going to burn. Customer brings a vehicle into you, and it overheats when you're driving in town. Above 35 miles an hour, you have enough airflow through the radiator, you don't need the fan. When these go bad, they fail in town driving. Put the scan tool on there. With the scan tool, if you can command the fan to come on, command it to come on, you'll hear this click, but the fan doesn't turn on. You're going to check to make sure there's power here. You can jump across there, and the fan will run, and it's going to seem to you that it just needs a relay. You can replace just the relay, and the car is going to leave. It worked just fine for anywhere from a week to a month, and then it's going to toast the new relay, and they'll be back with the exact same problem. When you find a relay with a burned contacts, find a bad relay, you replace both the motor and the relay to fix the problem. So testing your cooling system, and this can be anywhere from a customer complaint of the heater doesn't work, or the engine's overheating, or making sure the engine is going to operate at the proper temperature. First thing, pop the hood, check your coolant level. If the level is low, look for leaks, or if there's any indication of a leak underneath there. Pressurize your cooling system, look for any leaks, get those fixed. Do a visual inspection. Look at the hose, the clamps. Is the vehicle 10 years old? Take a really close look at those hoses. Looking at the radiator, if you can look on the inside, look at those tubes, those passages through the radiator, make sure that those are clear. Look through the front, make sure there's not junk that's going to restrict the airflow. You're going to check to make sure that the fans work correctly, and look at that water pump weep hole. Connect a scan tool. Hopefully you're about 150 degrees or cooler when you go to do this test. Start it up. I keep the hood open. I bring the scan tool out with me under the hood. With the engine running, I'm going to keep coming over and checking that upper radiator hose. When the radiator hose gets warm or gets hot, the thermostat opened, I'm going to look at the temperature of the coolant. Hopefully it's going to be that between that 180, 195. If it's below 180, I'm going to replace it. If the customer is complaining about an overheating and it opened at 170, well, it's definitely not the thermostat. Keep the engine running. And you want to keep the RPMs up so the engine's getting hotter quicker. Temperature's coming up. At what temperature does the fan come on? Different manufacturers will turn it on at different times. Some manufacturers will turn it on as low as 202, 205 degrees, somewhere in there. Other manufacturers are not going to turn the fan on until about 220, 225. The worst one I saw was 235 degrees before the fan kicked on. And I thought that was crazy, especially for an engine that had a cast iron block and aluminum head. Once the fan kicks on, keep the engine running until the fan shuts back off. Now you know the system cooled back down. And here's the scenario. I was working on a car similar to this. It's Trans Am. Customer brought the vehicle in. They said it's overheating just while they're driving down the road, not even loading the engine. So, okay, I was checking the system. I did all these inspections on there. Everything looked good. Upper radiators got hot. I actually pulled the radiator cap off and I could see that there was flow through there. So, okay, the heater or the water pump is doing its job. Put the cap back on, kept it running. Fan kicked on. I could feel some heat coming out of there. I just about shut it off and finished my test to say there's no problem found, but I thought I'm going to keep it running. And the engine's sitting there running, the fan's running, I can feel the heat coming off of there, and a few minutes later, the water is boiling in the overflow tank. All right, shut the engine off. Trying to figure out what's wrong with this, man. Everything looked good. Good flow through the radiator, both coolant flow, airflow. And then I remembered, I went to a class, and they were talking about this air dam. So this piece right here, which sits right underneath the radiator. And especially on this particular vehicle, which has a V8 sitting right behind the radiator, when the fan kicked on, the engine is sitting here, the radiator is sitting at an angle like that, and this air dam is supposed to be right there. But on this vehicle, they'd used that air dam as a curb feeler and broke that off. Now, as the fan kicked on, the air was just circulating around like that, and the engine overheated. So I was sitting there racking my brain trying to figure out why, and then I remembered, oh yeah, I looked underneath there, and sure enough, that thing was broke off. Told her not to drive the vehicle, because of course we didn't have one in stock. That I would not recommend driving this vehicle because it is going to overheat on you. And a couple days later, we got the new one in, put it on, problem solved. Make sure that your cooling system is working right. Once that fan turns on, keep it running until the fan shuts back off. Hope that helps you to understand the cooling system and how to test it. We'll see you on the next video.